Hey class, today we're going to discuss completing the square, which is found in section 4-6, part 1 of your book. We will solve equations by finding square roots, and we will solve a perfect square trinomial equation. In our first example, we will solve by finding square roots. What you should notice for the first equation, 4x squared plus 10 equals 46, if we think about standard form, what happens to be missing is the b term. So again, standard form, just as a reminder, would have been y equals ax squared plus bx plus c. And so we're missing the b term, the one that just has a single x attached to it. So since that's the case, we can actually solve this by using square roots. So we would, on the first one, subtract 10 on both sides and be left with 4x squared equal to 36. Next, we're trying to get x by itself. That's our goal. So we would divide by 4. So x squared equals 9. Last, we would take the square root, because opposite of squaring is square root. So we would square root both sides. And we get x equals plus or minus 3. And that would be our solutions, or those would be our solutions for the first problem. Next, same thing, we would add 5 to both sides and get 3x squared equal to 30. Divide by 3. And so x squared equals 10. Finally, we would take the square root. And so x would equal plus or minus, and we're not going to break down 10 right now, so it's plus or minus square root of 10. Okay, let's do our try. Alright, so in try 1, again, we're going to solve by using square roots, so we're going to add 10 to both sides. We would get 7x squared equal to 35. Divide both sides by 7. And so x squared would equal 5. Finally, if we take the square root, we would get that x is equal to plus or minus the square root of 5. Alright, let's look at the next one. If we subtract 9 from both sides, we would get 2x squared equal to 4. We divide by 2. X squared would equal 2. Finally, if we take the square root, x would equal plus or minus the square root of 2. Alright, in example 2, it says, while designing a house, an architect used windows like the one shown here. What are the dimensions of the window if it has 2,766 square inches of glass? Okay, so if we're talking about that the architect has 2,766 square inches of glass to complete the two pieces of the window here, then technically we're talking about area. So we have two figures here. One is a rectangle and one is a semicircle. So let's talk about the rectangle. The rectangle is fairly simple. That would just be area is length times width. And the semicircle, first of all, the area of a circle is pi r squared. So if we have a semicircle, it's half of that formula. Okay? So now all we do is substitute the information that we know so that we can find the area of each. Okay, so the area of the rectangle, the length we can say is x, and the width is 2x. So x times 2x would give us 2x squared. For the semicircle, once again, we substitute. So we have a equals 1/2 times pi. We're just going to leave pi as pi. The radius would be not x, because x is the diameter, but the radius would be 1/2 of x, and that's supposed to be squared. And it looks a little confusing for now, so I'm just going to continue to write the 1/2 pi in the front. Whenever you square a fraction, you square the numerator and the denominator. So I would square the 1 and I would square the 2. So 1 squared is 1. 2 squared is 4, and then x squared is x squared. And then finally we need to multiply those two fractions together. So 1/2 times 1/4 is 1/8. And so this is 1/8 pi x squared as the area of the semicircle. Now here's the deal. We have to set those if we're talking about the area of the glass windows, we have to combine the area of the rectangle and the area of the semicircle, and we need to set those equal to 2,766 so that we can find the value of x. So this is what we'll do. 2x squared plus 1/8 pi x squared is going to equal 2,766. Okay? And then from here, we have a little bit, a few things going on here. We're going to need to factor out or take out our greatest common factor from the left side. If you notice on the left-hand side, they both share an x squared in common. So we're going to factor out x squared, and we're left with 2 for the first one. And then for the second one, it would be pi over 8, or 1/8 pi, it's the same thing, equal to 2,766. All right. Next, again, our goal is to get x, or x squared by itself. So we would notice they're being multiplied together. X squared and 2 plus pi over 8 are being multiplied. So we're going to divide both sides by 2 plus pi over 8. Now that's probably a lot going on in your calculator, so let me walk you through how to do that. The very first thing in your calculator, by the way, this is gone, and so I'm left with x squared equal to some number, and I'll tell you what that is in just a moment. We would have, and actually I lied, let me erase that. Okay, so in our calculator, the way we would solve this is we would say pi divided by 8. Whatever that answer is, you would then add that to 2. And then whatever answer that is, you would say 2,766 divided by that previous answer. And so x squared would equal that number. And then finally, to get just x, we would need to take, and that's about, sorry, we would take the square root of whatever that final answer is, and what you'll notice is that you'll get positive or negative 34. Now here's the deal. Length can never be negative. Notice we're talking about the dimensions of the window, so length can never be negative. So we will use positive 34. Okay, so that means that our final answer will be x equals 34. So if we're talking about the dimensions of the window, this is 34. Then the dimensions of the window are 34 by 68 if we're talking about the rectangular window. All right, and so that's it. Let's go ahead and move on to our next example. All right, and the try says the lengths of the sides of a rectangular window have the ratio of 1.6 to 1. The area of the window is 2,822.4 square inches. What are the window dimensions, or the window's dimensions is what it should say. So if I drew a window, and this time we're only talking about a rectangular window. We are not talking about a rectangular window and a semicircle. Okay. So the dimensions are 1.6 to 1. And remember, if I'm using 1.6 to 1, we don't know exactly what the dimensions are yet. So we need to put an x as a variable next to it. Okay, if area is length times width of a rectangle, the rectangle's length here would be 1.6x times x, which gives us 1.6x squared. Now that area is our 2,822.4. So to get x by itself, we would divide by 1.6 on both sides. And this would then equal x squared. Finally, we would take the square root of both sides. And x would be, Actually, let me just back up for just a second. So let me get rid of the absolute value sign. Okay, so x squared would equal, we would have to do 2,822.4 and divide that by 1.6. that would give us 1,764. And then if I take the square root of that, x would equal 42. And technically it should be plus or minus 42. Now again, we can't have a negative 42 or a negative number for dimensions. So positive 42 will be our answer. So the dimensions are a 42 by, that's 1.6 times 42. So our answer here on this side would be 67.2 because we multiply 1.6 times 42, which again gives us 67.2. So those are the dimensions of our window. All right, in example 3, it says, what is the solution of the following expression? Okay, this is the first time that we're going to kind of start talking about, well, we kind of know a little bit about perfect square trinomials, right? We talked about those in a previous section. So the first thing that we're going to want to do is deal with the left side only. Okay, I know we're used to moving that 25 back over with the other parts so that it would be in standard form, but actually if you notice already on the left side there is a perfect square trinomial. And remember, we know that it's a perfect square because if we take the square root of the first part, which is x, take the square root of 4, which is 2, the center should be 2 times x times 2, which is 4x, and that is what we have. So since that is the case, and this is positive, this should be x from here plus 2 from here squared, and it's going to still equal 25. So again, this is all about recognizing if you see a perfect square trinomial. If you don't see a perfect square trinomial, then you will continue to move the 25 over and put it in standard form and solve as normal. But again, here we notice the perfect square trinomial on the left side, so we'll solve it this way. Moving forward, we take the square root of both sides so that we can get rid of the squared on the left. So we're left with x plus 2 equal to the square root of 25, and we know the square root of 25 is 5. Finally, it should be plus or minus 5. And so at that point, we will set x plus 2 equal to both plus and negative 5. So x plus 2 equals 5, and x plus 2 equals negative 5. So if you subtract 2, x will equal 3. If I subtract 2 on the other, I'll get x equals negative 7. And so those will be our two solutions here. Let's try the next one. Again, the first thing we want to do is try to recognize and see if the left side is a perfect square trinomial. So remember to try and see if it is. Take the square root of the first one, which would be x. Take the square root of the second, which is 7. And check to see if the center term is 2 times the first times the second, or the last one, which it is, except this is negative 14x. So that means this 7, when we rewrite it, is going to be a negative 7. So here we go. This will be x minus 7 squared, set equal to 25. We're going to take the square root of both. So x minus 7 equals 5 again. And again, that's plus or minus 5. So we need to rewrite both. So x minus 7 equals 5. And then the other one is x minus 7 equals negative 5. Okay, if we add 7 to the first one, we'll get 12. If we add 7 to the other, we'll get x equals 2. And again, those are our two solutions. And guys, that is it. So again, if you have any questions or if you need to come in for tutoring, please do so.